Right. We're going to keep on learning about Python today, and we're going to practice some of the fundamentals in Python.
Give me 1 second. So Jupyter notebooks, right?
Yeah.
I'm here.
Okay, so if you go to Jupyter Notebooks, I just created a folder here, Jupyter Notebooks with you guys. Are you guys all here?
Yeah.
So if we click create or upload files.
Okay, there's a lot.
Okay, so did you guys go to create or so basically if you click here, you go, or you can go to new. You guys click new? Are you guys all here?
Yeah.
The new, and then I can write my name, Sanya. We go one step at a time with me, please. Sanya is notebook, okay? So this is a Jupyter notebook, okay? Did you guys all write your name, Sanya's notebook? So have you guys done this? So have you guys all written your name here? And then the next thing they'll do is Jupyter notebook.
Okay.
Have you guys done that? Like one step at a time. Have you guys all done that? Like Jupyter notebook.
Yeah.
Then the next thing to do is to do Python 3 Ubuntu Linux. This format.
I don't see that.
Yeah, I don't see the quick select either.
It says this notebook has no kernel.
Oh, okay. How about you guys? Somebody share the screen, please.
I can do it.
I can. Okay, you do it.
Sorry. It says a working kernel is required in order to evaluate the code in the notebook. Please select one for the programming language you want to work with.
Oh, okay.
Oh.
This right here. You want this right
Found
here.
it. Which one is it? Sage Math, Ubuntu Linux, or IPy kernel?
This one, Ubuntu Linux.
This one?
Yes. Did everybody have that?
And it took me to this, or 1 second, let me go back. How do I go back? I don't know how to go back, but I selected that.
Okay. Oh, yeah, that's perfect. That's perfect. Great. Awesome. So we'll talk about that. Great. Did everybody have that?
No. Wait.
Oh, so basically what you do, there's like this kernel tab on the upper hand corner. It should be next to help, between help and cell. Click on that, and there's change kernel options, and then you can select the option you want.
I don't see. Oh.
So do you see it all like under all
there it is. There it is.
Yes.
Or you can do that actually. I made it up.
It's a kernel and then create custom kernel.
No, got you. You can just scroll down and look at Python, and it's right there.
Yeah, Python, and then Python 3 Ubuntu Linux.
I didn't notice that.
Right. Yes.
Do you all have it? Ubuntu Linux, UBUNTU Linux. It's just one format of Python that we're going to use because we can have certain packages loaded in already. It makes it a little bit easier to work with. Okay, great. So this is what we're going to work with Python. So why do you guys think that Python is important for us to learn? So, and again, you've had some Python experience, right?
Yeah, I can answer that. Because Python is overall, it's the most used language of coding. And that's why we need to learn Python, because it kind of serves as the basis for other coding languages. It makes it easier to learn.
Oh, okay, great. So the idea is that if we want to learn Python in 10 minutes, Python is a programming language, but it's fairly useful. It does a lot of things. It can automate a lot of things for us as well. And as a programming language, it gives us a lot of flexibility to do, to basically automate tasks, come up with predictive models, do various things. There's a lot of advantages from programming languages like Python. It's a very hot language. It's a very up and coming language as well. But let's say you guys want to learn Python in 10 minutes. So then we could look up, okay, on Google, how do we learn Python in 10 minutes, right? And so one of the things we could do is, they have some videos here as well. But there's one, for instance, that, learn Python in 10 minutes by Gaurav Jain, right? So we can view this example here, what we will be kind of going through more. So everybody feels like they have some idea, of Python, right? People are more beginners, right? Has anybody here never learned about Python before? Please just raise your hand or let me know. Okay, yeah, we have a couple people, but others are more like beginners in Python. So that's also good.
I know what that Python is like a coding language, but I've never like learned how to use it or learned about it. So
Okay, so yeah, we're going to look at this source here more after the break right now. But one of the things I wanted to show you guys is about, yeah, Python is really, really important programming language. Okay, here. So yeah, there are lots of resources to learn Python language, right? So basically, this is, before we start with this link here to learn about Python, I want to see if you guys have all opened up your notebooks. So I'm going to go to the file, see. So we have all our notebooks here, and then we can just write our first variable. We can do like print hello world. I'll just do it the same way that a lot of people talk about it. This is printing out a statement. Hello world.
Oh, I know this. I remember this. This like typical one.
Yeah. And it will print it out. So right now nothing is run, but as soon as something is run, this will fill out hello world. Yeah, hello world. Then the next one I want you to write is my name. And my name, we can have it as your guys' name. Mine is Sania. Okay.
Wait, quick question. So how do you how do you make another in though? I just pressed enter and it just adds. Oh right, it does add another one, but
Oh, to add another cell block, you add the plus sign. And then if I could rearrange this out here more, then maybe I'll just show this for now. And then if you want to move maybe my name above, then this is how you reorder cells like this. So this is my name. And I can do either one. I can have my name here and then run it by itself on the next line. See, if I don't have anything, if I just have this, then it just assigns it and I don't know what's happening. I mean, I just know that this is assignment. So this is print my name. Or I can also have like my name here, either one. My name has Sania, and it's called a variable. A variable called my name holds the name Sania. It's a variable. So in variable, we have the word vary. Does anybody know what vary means?
changing.
vary means like change. Sorry.
Yeah, no,
That's
great.
what,
Variable is like vary.
how do you get like
So one thing about Python is you always need a variable name equals and then some value to assign always goes on the right. It's not like in math class. In math class, you might have something like you could either say x equals 4 or you could say 4 equals x, right?
Yeah.
You see that like in math class, but you don't want that. Especially 4 is a fixed number. You do not want the second one. The second one does not work in programming. You only do this top one here. The variable x equals 4. Does that make sense? Variable name equals some value to assign. So whatever you're assigning to has to go on the right. It won't work the other way around. So we cannot have 2.345 equals a. Unless if this was a variable, then we could do it. Like, we could set another like b equals a or something for this.
like all the in1, in4, in5.
Oh, so what these are is you have to run the code. So what happens is right now, this means it's not executed. And then when you click the run button or control enter, but you can click the run button, it'll then fill. So what's important, and I was going to talk about that next, is to keep track of these numbers here. These numbers are your guide. Whenever you run code, they keep, see right now, okay, great, you're on to a more advanced, this is great. And we'll talk about input today. You have not run this cell here. So if you, okay, so you're on to more advanced, okay. 2 and 1. What this means is that you started out this first and then you move this one next. So the smaller this number means that like this happened before this happened. But if I were, you see this is 1 and 2, but if I ran this one, if I run this again, 1, 2, this one is 3 here.
Oops, sorry, I was messing around with something.
And no worries, that's how you guys learn. This is 4, right? This is the 2, 3, 4. This sort of keeps track. So each time I run this, it'll update. The number tells me which, because I can move cells up and down. So it's helpful for me to keep track of the order that I've done things in. This is one. I've done this one first, then I went here, then I printed out my name. You see that? Even if I move this up here around, it will say I did this one, then I did this one, then I did this one. If I run this, do you know what number this would be next? If I run this cell, each of these are cells. If I run this cell, what number should this be?
3 or 2?
Okay, I'm gonna see what happens. It's 6. Why was this 6?
It doesn't, so it goes after 5.
Yeah.
Wait,
And if I run it again, it becomes 7. It's just like a counter. It's a keeping track of the order that I did things in. So this is the 4th one, then I did this one, then I did this one most recently. So the smaller the number, you don't have to worry about the specifics, you just have to worry about the relationships among them. So if this one number is bigger than this, then this means, but if I run this again, what this is showing is this is the smallest number. So I first did mine. So what happened is the oldest activity I've done was run this cell 4. Then what's the second smallest number is 7, right? Then I've done this. The most recent event is always the highest number in the cell. Does that make sense? The most recent event. You see that? Like if I run this cell again, this is 9, right? It's the highest number. If I run this cell, it's 9. If I run this cell, it's 10. So it's the most recent. So the most recent has the highest number. Okay, so we did a print hello world, and then we have our name as a variable. Here, you see all of this right now, guys?
Yeah, we can see it.
Okay, great. So basically, then the next thing that we can do is, so this is how you can print out a variable. And if you run this again, this is now hello world 12. This is printing out our name as a variable.
So this out thing, it tells, wait, so quick question, this out thing, it tells you which time the code is, right?
Yeah, it's sort of like the higher the number, the more recent it was updated. So even if I were to run this again, this one, what do you think this number should be next?
That one? It would be 16, I believe. Or would it be 20? I'm not sure.
Okay.
Is that 16 or 20? Oh, it is 20.
20. And I run it again, it's 21.
Oh, I see.
Have you guys ever been to so I don't know if they do this in Trader Joe's or some of the places where sometimes, a counter of how many people come in to visit a store, maybe how many visitors have we had today? You might see it in shows or movies. So it's similar idea to that, like keeping track of that. So in some ways, it's keeping track of how many times you've executed something. So it's 21, 18, 19, 12. So it's keeping track of it. Is that like anytime you run this, even if I run this one again, it'll be 22. It's just a counter, like, when each cell was most recently run. It's like a counter. Anytime I hit the run button, some cell gets updated, the number. You see, some cell gets updated if there's something inside it. The type of this variable is really important because we can do certain operations or certain things with certain types of variables. So my name is an str. This is to view the type of data. Does anybody know what str is short for?
Yeah, str is string.
Okay. Wait, 1 second.
Basically, should I say what a string is?
Yeah, if you want to talk about what a string is, that would be wonderful.
Okay, so essentially, strings are essentially different functions. It's a function for a specific type of code, and a string essentially is how do I say it? It's a sequence of characters, I guess you could say, and you can have more than one. So the parts of the string, they're like I think they're called like the elements of the string, if I remember correctly, and I think that's all I remember though. But
okay, yeah, I think that's great. Thank you for sharing that. That's really awesome. So yeah, this is a type of the data. So we can have multiple types of data. So strings are typically in quotes, if we go back and we change this to being like my last name as well, Sanya Kuller, and then we run this, you see it's like it gets updated, right? You see that? And then if I run it again, I will know that my name is Sanya Kuller, for instance. You see that 16 and 17, my name, it gets updated. Like if I change this here and I run it, then this will become 18, and then that means that this was more recent than this. So I need to run this to update this here, and then this becomes 19. So this is Markdown, and it's called an i.pynb. The extensions to these files are .ipynb. A typical Python file ends in .py for Python, but this ipynb is an interactive Python notebook. You see that? That's what it is. It's interactive because you have these cells and you can run code and see the content there. So that's why it is interactive. So because it's an IPython, I could even have Markdown. Markdown is just like text that you can use to visualize. So this is numbers, and I with two number signs. So a number sign, again, this is how you add a comment. This is a comment. A comment has the hashtag sign, and this will not be read by Python. This is just for you to write comments for yourself. These are just comments for yourself. Do you get that? These are just how you add comments is with a hash, a pound
Wait, so
sign.
what exactly are we supposed to type right now?
So, okay, so
hashtag numbers with two hashtags?
Yeah. But you'll notice that this cell says code. All of these say code here. But if I want to add headings, I have to change this from code to Markdown. If I keep this as code here, it won't complain because numbers are comments, but it'll look like this. But if I make this a Markdown, it'll look something like this.
Oh wait, what is Oh yeah, Markdown does look like that.
And then if I instead do numbers, like let's say I start with number. I don't have to start with these pound signs, but let's say I do numbers.
Wait, so do we keep that? Quick question. Do we keep that as the Markdown, like as the heading?
Yes, you keep that. But what do you notice happens? So here, if I click them, I can edit it. I had 2 here and I had 3 here. What do you guys notice as I'm adding additional number signs? Like, let me run it again.
The Markdown text gets smaller.
Yeah, and that's sort of like how HTML works with headings. You know, like with HTML, as you have headings 1 to 6 as well, and the bigger the heading number, the smaller the text. So as we have more number signs, you see that the text size is shrinking from here to here, right?
Wait a minute. Why is mine not working like yours? I don't know why.
Because when I type the 3 pounds, it goes to orange instead of blue.
Yeah, because numbers is like a special comma.
Wait, why isn't mine working like yours though?
So these are some special text. Okay, so Alexander, let me see your notebook.
Yeah.
Oh yeah, it is working.
Oh, it doesn't look. See, like it's not showing that. Huh?
You just have to change this from code to Markdown.
Oh, it doesn't show like that on mine though. See, because for mine it looks.
Oh,
like...
you just have to run them.
Oh, because for mine it just looks like straight lines, and it doesn't look like that.
Oh, you have to make sure that the type is Markdown, and usually
yeah, see, it looks like that. It looks more like this.
Oh, you just have to click run.
Yeah.
Does everybody have this working?
Got it.
To add italics around a text, you just need one italics, the star sign. You see that one star sign is for italics around the text. In the front, italics around a word. Or a set of words.
How do I get the heading? I didn't get it.
Oh, okay. Let me show you the heading. For this? Oh, you just have to click Markdown.
Huh?
See that?
Oh, yeah.
Wait,
okay.
that didn't work. Can you go back real quick?
Oh, you just have to go here to Markdown. So they just have to click. So if I write this as code, it probably looks like this. But if I want to make a nice heading, I can add Markdown. I don't even need, and I can run it. I don't need to have number signs in front. If I just don't have number signs like this has no number signs, it looks something like this, which is okay. That's fine too.
Just go to your notebook real quick and copy something.
Oh yeah, of course you can go there.
Wait.
This is not working because this is the code. You see, this is code. You have to change this cell to being marked down. Do you see that? It has to be marked down. Otherwise, this is code right now. You have to just change
it to Markdown though. Oh,
and now it works.
Oh, I see. Okay. Got it.
Yeah. You just have to be careful. But this is just how you can write paragraphs or other thing. Or like it's just you can do other things. You can add formulas as well. When in fact when you add in Markdown, they typically show you, Markdown LaTeX. You can add exponents. You see how they show you some examples there. But that's just how you can make it nice and neat. So now we're going to talk about variables like numbers. Does that sound good? We're going to talk about numbers, how those look as well. So basically, we have numbers like a equals 3. This is a variable, a equals 3. And this is a comment, integer. A is an integer. So this is a. If I want to see the type of a, oh, sorry, I need to make this a code. Now it's coded as a code. So a is an integer. Does that make sense? If I want to see the type of a, how can I see the type of a? What type of variable?
Maybe you could put type a.
Yes, exactly. And so this is 24. If I run this will be 25. It just helps me keep track. This is int short for integer. We're kind of lazy in CS. Sometimes we write int for integer. We write str for string. So int
Shorthand, right?
is short for integer. I can also have a float or double, another type of number. A equals 2.345. And then I have a here. And this will override. Basically, we can override the variable. Like so Python, some programming languages make this a bit harder, but Python, we can override the value of a. So now a is going to be 2.345. So you see that this is cell 26. It's a 26 execution, right? So now if let's say that I were to run this, type A, it's going to say float, right? But you might get confused. Imagine if you're working your way down from the top. You might say A is 3, then how come A is a float? You see that? Okay, reading from top to ideally, you should be writing your code so that if you run it, the ways to do kernel, restart and run all will be like running everything from top to bottom. But sometimes when we're programming, we might not think in the right way. We might be reshuffling. Remember I showed you those up and down arrows, right? We might not be coding in the right order. It doesn't matter. There's no rule stopping us. But when we run the code, we should run it from top to bottom anyway. So if we said A is 3, and then I'm doing type A, why is it float? Does anybody know why? The hint is it has to do here. But now I'm doing type A, right? Like let's say I was looking here, A is 3, then how come the type A is a float?
Because what you did was when you typed A equals 2.3.45 and then A, it overrode the A equals 3 command. So now A is defined as 2.3.45 and a float is defined as a non-integer number, or in other words, a decimal number. And so in this case, now when you're typing type A is now overridden. The A equals 2.3.345 overrides A equals 3, and therefore A is a float.
Yes, exactly.
And also, it's because I believe it's because the A equals 2.345. It's after the A equals 3, which means the code after overrides the code before.
Yes, Alexander, that's exactly right. This A equals 2.345 overrides this. And how would you know that? It's because you would see that this is the cell 26 and then this is cell 27. So this happened more recently, right? So I did this. Then what's the next smallest number? So the way that it goes is this is, okay, this is 24 here. Then what's the next smallest among 24, 27, or 26?
So 26 is smaller than 27, but when I run it, I still get out 11 is equal to int.
Yeah, but because probably you didn't run it in this order. Yeah, it should be like that. I just reran it. So what happens is, you don't worry about it. I'm just showing you an example. So
Okay,
I ran
cool.
this, then I ran, this is the second move, then this is the oldest thing I've done. This is the next oldest thing. You see by the numbers. Then the next oldest, which is the most recent, is this one. You see that? By the numbers,
Okay.
26 goes to 27. So
I
what
got float now. Yeah.
So that's what happened. And sometimes you may get confused, right? Like if you're going back, you're like, wait, why is this a float? So these numbers, and you sometimes I might sound like your parents or teachers, sometimes when you don't believe them. I used to have people telling me that it's important to write efficient code because code takes days to run. And I used to be like, I don't know why code would take days to run, right? What are you guys saying, huh? The people are exaggerating. Till I got to the stage where sometimes code does take hours or days to run. Do you understand that?
Yeah.
Yeah. So essentially, the most recent command is the one that Python processes, right?
It's the most recent one. It's just to help you keep track of these orders.
Yeah. But the one that overrides the other is the most recent one, correct?
Yeah, the one that overrides it. This one is more recent than this. That's why A has this value. Do you see that? A has this value because this is 24. Then this is the most recent one, right? Do you see that? Because it's 26. But then if I run this again, this will be 28, right? And if this is 28, then this is the most recent, right?
Yep.
So then the way that it will go is it'll look something like this. You did this, then you did this, then you did this, right? So, and then now it'll say, okay, well, maybe A was 2.345. Then you did this, then you did this, right? It's just like, it's keeping track of the most recent. Now, if I do type of A, then this will be 26. This is something that you learn from programming more, but I'm just trying to teach you the little tips and tricks a bit. Stuff that I've learned the hard way. This one, this is 28. Then this one. Now it'll be an int again. Do you see that?
Yeah.
So
I
that's
also noticed. Oh, sorry. Go ahead.
Oh, no. I appreciate the interaction. So that's why it's important, because I'm trying to show you, because you might end up down the line. It's very sad to see how many new programmers doubt themselves thinking, oh, I wrote the code wrong. That's why it's not working. When it's something very minor, maybe you just mix them out of order,
Yeah.
and it's something so
Also-
tiny.
Yeah, something I also noticed was that on the rightmost side of the boxes, it tells you how many seconds it took to compute the program. So
Oh yeah, that's pretty cool. So
yeah,
now
example 0.6. It's kind of like Google. I think there's like this one time where I saw Google like X results found in X seconds.
Yeah, like sometimes some searches tell you, yep, it tells you. So you can see sometimes what are some of the fastest codes, what is slowing you down. And just for simplicity, what I want us to do is, like, let me just say kernel restart and run all. Your goal is to run all and to have it execute from the beginning. See, if I restart run all, you see this will complain. Do you notice that? My name is not defined. Do you see that error right now?
Yeah, I actually have 2 errors for some reason.
Yeah, that error is because I call my name before I declare it. You see that?
Yeah,
So I need to move this down, and then I need to rerun this. You see, now I'm rerunning it.
Wait, what? So you go there and then you rerun it?
Yeah, so the way to do it is you can do kernel, restart, and run all. Your goal should be to reorganize if you have to up and down certain cells.
Oh,
Doing this up,
wait,
move.
Can you do that for me real quick?
Oh,
Still not
yeah. Okay, Alexander, let me check. Type my name. Yeah, so you need to move. I don't think you defined, okay, you have my name equals about this X. You needed to not make it Markdown, but as code. That's why.
Oh, wait, was it Markdown?
Yes. So I'm saying that so many times these mistakes can be very simple mistakes, and then you can doubt yourself. And when you do code, and so yes, and that's exactly it. Sometimes you'll write code And you might have been shuffling it and it might not work again because we defined my name. So I had moved this above. I had moved this cell above and it was running because my name, when I'm doing restart run all, I'm saying chuck everything that you remember, all the variables, they go in some memory space. It's called some workspace. When you're running Python, all these values have some meaning. When I'm doing restart run all, I'm just saying, and when you reload a project, you might have to do it. When I'm doing restart run all, I'm saying throw everything out that you know and just start from the beginning. Because that's how code typically goes. You want to run this cell, then this cell, then this cell, then this cell, right, in order. It's just that when you're programming, sometimes you might not, like, you might be changing things around, right? Adding a cell, moving, you know what I mean? Like if you guys are writing an essay for school, I know I do this sometimes. I might have like one clean paragraph done, then I'm shuffling, writing some other, if you're writing a research essay or some essay about a book, right? You end up having some clean stuff, then some not clean stuff, right? Having a few different moving around, moving some sentences around in your essays, right? It's like that. So when you're doing it, then at the end, you want the essay to read neatly, right? But in the process, it might be you might have like this paragraph done, then you have your body paragraph, and then part of your conclusion done. It's like that for programming. So it's how everybody wants to think. And there are multiple ways of doing something. So now I ran this and this type A. A is an int here. But now if we do this, this overrides A. We can have variables with anything as long as you have.
For my variable name equals 5, it says error when I tried to run it.
Oh, yes, because you had this, you have not defined this. If you do not define a variable, then variable name is not defined.
Oh yeah, because she changed you have to have both of them as the same one. For example, one of them used an underscore and one of them you didn't. So you have to change both of them to be the exact same one.
Yes. And one thing I want to stress to you guys is that you may have this as variable name, but how many times I've seen students do this where they'll try, like I recommend copy pasting the name. Some people might do this, misspell it, just copy paste it. Some people, this is going to complain. You might think, oh, doesn't Python know? Right? Why doesn't Python know that this is the same thing I mean, right? You might be saying it's trying to be cute, right? Or being a troll, right? But it doesn't know. The poor guy is going to say, I'm going to do exactly what you tell me to do. You said variable with a capital N is this. I don't know what this is, right? As a human, if you were seeing this, you'd be like, yeah, I know that this is 5, right? The person probably meant, or imagine if you have this, but you accidentally forgot the E, right? You'd expect a human to guess that, but what happens is that the computer says no. You could have another variable name called like 1, and that would be valid. Everything, it does not know better. It does exactly what you tell it to do. You see, like this is different from this. Now, if I call variable name again, it's going to be 5 because this is a different spelling. And so if you make a mistake with the program and it's not doing what you want it to do, chances are whose fault is it? Your fault or the program's fault?
I'd say it's maybe a mixture of both.
I mean,
probably your fault.
Yes.
Because either you're running it wrong or you typed something wrong. And that's affecting the way that the program can actually react to that and how it can process it. Yes,
exactly. As Alexander said, it's probably your fault. That's why people typically variable name. If you have multiple names, you can use camel case, variable name. Or you see where it's basically one word and the next word is shown by a capital N, right? For instance, variable name equals like a 5 or something, right? You can have a variable name. I'm just using A for simplicity. And then you can have variable name like 5. You could also have variable underscore name equals 5. You see that? People typically use this more, but you cannot have a space. The variable is typically preferred to use this camelback. Different languages like Java, or it depends, but people typically use this. The first letter is typically lowercase in a variable. And then the next words are capitalized. Does that make sense? These are some typical protocols. They just hold a value. You can even have scientific notation. Here, you see how this comment helps you guys see what's going on? 10 to the 3 is just 1000. You could also have A like this, but this E is just saying times 10 to the. You see that? This is if you had A equals 1 E to the 4, then this would just be like equivalent of E equals this. You see that? You guys understand what this is? I don't typically use that much. Lowercase e or uppercase e is the same thing here. Programming languages, they can help you automate tasks repeatedly. If there's a mistake in what's happening, chances are it's your fault. The programming language is only doing what you're telling it to do. And if this is blank, sometimes you guys might say, why isn't this working? Well, if this is blank, that means you have not executed it yet. So it needs to be evaluated. And as Alex pointed out, there'll be probably no number next to it, right? About how long it took because it hasn't been executed. I really like IPython Notebook. I find it very convenient. We can add something like this. This is like now, please note, we can do some math operations with integers, floats.
So like, for example, like if you're given 3 points and you're asked to find the incenter, can Python calculate something like that?
Yeah. But to do that, you have to write a function or see if somebody else has it. We'll get to that actually.
I was messing around with some stuff and I noticed this thing changed. Can you come over here to mine real quick?
Okay.
I was messing around with this. If you scroll down, it says less than a minute ago now. On the side here. Instead of seconds, it says less than a minute ago, which I think is interesting. Like, why do you think that happens?
Oh, you wrote a giant loop. It's gonna take a long time to do this. You're gonna break the server.
That was kind of the intention, but
yeah, you're gonna break the server that way. It's trying to go through a large giant thing. So yeah, try not to, you can do it for fun, but just be careful. You don't want to crash.
Yeah, I was just messing around, but it does. What I thought was interesting was that it said less than a minute ago, which is interesting.
Oh yeah, for long code, that's what I mean. Some code can take a long time. With numbers, you can do operations. You can do addition. You can have C. So now we have A and B loaded in. So B is a float if we did type B. And you can call variables anything as long as they're one word. It can be underscore. This is not as popular as this approach, but you have to be careful that the spelling is right because otherwise Python will only do what you tell it to do. So chances are if it's not doing what you want it to do, it's your fault. Now, if I change A, like now you see how I run it. A is 3, B is 2.5. So if I do C equals A plus B, C is now 5.5, right? Now I can change A to being 4. What should C be?
C should be 6.5.
Okay, you see, and so Alexander, you said C should be 6.5?
Because you added 1 to A, right? So
okay, that's a good attempt. What else does somebody think?
Okay, never mind. I'm not thinking here. Sorry, one sec.
No. I like the guesses. I'm trying to see where you guys are all thinking because these are things that as beginner programmers, I want to ask you guys for this reason to see if it's what you think it will be or to be surprised. So who agrees that it should be 6.5?
Never mind. That was a surprise. What is that?
Okay, so what did it end up being?
6.141592653589793. Wait, why is this pi? But instead of 3, it's 6.
Sorry, I don't see what you're doing. Let me check.
Huh?
Oh, you have
I just
B
ran
as
all.
this?
No, I ran all just now. Oh, never mind. I see what. What am I doing? I see now. I see what I was doing. I was messing around earlier, so.
Yeah. Okay. So basically, we have A is 3, B is 2.5, C is 5.5, A is 4. We update.
A plus C then. Never mind. I know what I did wrong.
Okay. So why is C still 5.5?
Huh.
Guys, why is C still 5.5?
Oh, I see why. It's because of the order. When you defined A as 4, it was after, right? Oh wait, no, you didn't.
Yes, it was after. It was after.
Yeah, because it was after. So now then, even if you put C here, the output would still be the same as before because it says what it is earlier, and then it doesn't change because A cannot affect the C equals A plus B.
Yeah, it's like C is assigned the value 5.5. I could have said C equals 3 plus 2.5 as well. In fact, what you can do is you can use Python as a calculator. 5 times 6 is 30. You can use it as a calculator. You see that? Multiplication. But the value is C was assigned. I could have done C this way, or I could have said like C equals 2.3 plus 2.5, or I could have said C equals 5.5. I could have done those. I just said, hey, just take the value of A, take the value of B, and make them 5. And that's 5.5. Even if A got updated, we did not re-update C. C is happy. C is content as 5.5, right? Like if you have friends, you're happy hanging out with your friends. If your friend strikes the lottery, right, you're still gonna be happy with that person. You still the same thing, right? Your C and your
mine didn't go. Like it says error for C.
oh, you have a period here. You see?
Oh, right.
So sometimes there are small errors, and then they might make you doubt yourself. So don't doubt yourself.
Okay.
See, B is not defined. And why isn't B defined? You have to run this cell.
So, okay.
So now this is 30, and then this says B is not defined because you did this, then you haven't rerun this. Now you have to rerun this, so this will be 31. Yep.
Okay, thank you.
So I don't want to give. Oh, yes.
Yeah.
If I rerun this right now, like let's say I reran this, C would now be 6.5. Do you see that? If I reran this cell here, C would be 6.5 because it would take the updated value of A. Does that make sense? If I ran this cell again, so I did 17, 18, this cell, this cell, this cell, and then I came back to this cell here. Do you see that? It'll take the updated value of A. Does that make sense? Gayu, does it make sense?
Yeah.
Just wanting to show you that the order of the cells matters. So this is C is 5.5 here. Another thing we can do is so that's addition. We can also do multiplication. C equals A times B. So what do you think C would be? Or it gives the answer anyways, but what do you think C would be? A times B. A is, okay, so A is 4 here. So A times B should be 4 times 2.5 is?
2.5 times 4, that would be 10.
Okay, yeah, so this should be 10. Yeah, because we're using the updated version of A. This is for A is 3. We can also do division. We do division. This is how you do division. A divided by B. So this should be 1.6 because 10, no, C is A, which is 4 divided by 2.5, which is 1.6. Does that make sense? You can even do like any number. If you want to do all these numbers divided by 9, you can use it as a calculator. You see that? It's like a nice little calculator, very quick calculator. So that's how you can do this with numbers. There are lots of operations with numbers you can do. We can enter some input for the user as well. This is how you can take user input. We can just say random number equals input. Please enter a number between 1 and 10. Do you see that? It's called input. This input takes input from the user. Whatever they enter, they assign it to something called random number. So for instance, please enter a number between 1 and 10. Somebody give me a number.
3.
5. Okay, we can do 5.3 for instance. Because that's both of you said it. So random number is then going to be 5.3. And this has quotes around it, which is actually what a string is. If we want to work with strings. This is strings here. So I made it a Markdown with these $2 signs just to make it big text for strings. So one of the variables for strings was my name. Do you see that, my name? If we want to convert something from a string to a float, we can just do something called float random number.
Wait, huh?
Okay, so I'm going to show you. What do you think happened from here to here? What do you see
Oh,
the difference?
so basically what happened was it changed the string to an output, I believe.
That has what? Does this have a string in it or not?
This is not a string anymore. Instead, it's a value, I believe.
It's a float, yes. So this is how you can convert, for instance, a string to a float. Or if you want to convert a string to an integer, then what can you do? So you see the type of A was float, right? For these numbers, it's called float. And when it's an integer, Python calls it int. So how can you call something a float, an integer? How could we make random number an integer?
Maybe we could put int random number.
Yes, exactly. That's how you convert it to an int. So if we run it and it converts it to an
So
int.
change it to, wait, it doesn't work though.
Oh yeah, it works with if it is an integer. So let's just make
Right,
this
yeah, you
like
have to
9.
change it if you want it to be an integer.
Yes. The random number is like 9 now, and float adds a 0 to it. If we do int, then it agrees. You see that? Because it had a decimal and it's like, I don't know how to deal with this. You see what I mean? It doesn't
I
know.
assumed it would actually automatically go to 5, which is interesting.
But yeah, but Python sees a period in 5.3 and it's like, I don't know how to make this an int. How to make that quote 5.3. It thinks a period is actually like, it thinks that the dot is a period, like end of a sentence. So this is how you can do conversions from a string to a float, string, str, to an int. So whatever the data types are, to convert it to some data type, you can just put float in parentheses. Like if we have B is this, we can turn B to an int though, because it's already a value. If it's an int, it goes from 2 to 2.5 to 2, and we slash out the decimal. You see that if we take B from before, if B is already 2.5, if we do int of B, it just makes it 2. Anyways, there's a lot you can learn about numbers. There's also strings, where we have my name. I can print out a message. Hi.
What about modulos?
Huh?
What about modulos?
Yeah, we can also do that. There's a lot you can do. You can find
Yeah,
remainders.
because I forgot how exactly to do it, and now it's giving me this weird thing in the in thing. Oh, never mind. It says waiting for another computation to finish first. I see.
Yeah, could you check mine? Because like it's not running the way I wanted to, because I wrote my name and it's not printing out my name.
Oh, you guys have to finish entering this. Then now it's doing it. You see that? You need to finish with the input. You need to finish entering it. Otherwise, it's going to not let anything else. It's going to have a square. Like let's say you didn't write anything here. It's not going to do anything. It's going to complain until you put something here. You see that? Now it's working.
I put in 9, but I don't know why it left it blank.
Oh, okay. You have to probably click enter.
Oh, okay.
And then now it's working for that. It's just kind of very fussy.
All right.
This is how you can print out, hi there, Sanya Color. Do you see that? If my name is Sanya Color, I can print out something like this with commas.
Okay.
I can print out A equals A and B equals B like this. I can have a print statement like this where everything is separated by commas. If I wanted to print the same message, hi there, Sanya Color. You see the variable name? Like let's say I messed up and I did this. It would say my name not defined, right? You have to be very particular. This giant and the capital N makes a difference. So it has to be like this. So similarly, what we need to do is if we wanted to print out a message to print, we can also do hi there. If you want to print out a message, if you want to do that, since my name is a string, you can add strings together. Type of my name is a string. So message to print is going to be hi there, Sanya Color. Do you see that?
Yeah.
Then I can also do print message to print. It's just some string. This type of this will be a string. This is also a string. Do you see that?
Yeah.
If I want to print out, let's say I want to print out values, right? I can do values equals this. You see, similarly, if I want to do this, Let's like this, I can print out the values. Plus, plus, plus. You see, instead of commas, I put pluses. If I'm printing out if I'm assigning it to a string, I have to put pluses. Otherwise, I have to put commas if I'm just printing it out. Do you see that? Like I can hi there, comma, my name. Or if I'm assigning it to a variable, I put a plus instead of a comma. Do you see the difference?
Yeah.
Okay. So if I try something like this, it's going to complain. So what does it say here?
I can only concentrate str a string, not int to string.
This is called concatenate. Concatenate means to add together. That's what concatenate means. It's a computer science word to add this to this. I can only add strings to each other, not int. So why is this complaining? Here, my name was Sanya Kula Smiley. So that's why it could work, right? This was a string and this was a string.
Yeah.
So here, what is this? What is A exactly?
A is an integer.
Yeah, and B is also some float, right?
Yeah.
So to convert it to a string, how can I convert it to a string?
Remove the values of A and B.
I mean, this is how you can convert to an int in brackets. How can I convert something to a string then? Similarly,
str. Oh, can I say it?
Mm-hmm.
Like use the str, I guess.
Yes, I can just convert them to a string like this, so it can add them together. Do you see that? Yeah. Do you guys see that? I just converted this to a string and this to a string, so I can add them together.
Check mine again because it says cannot assign to operator when I try to do the strings. Or did I like mess something up?
Oh, you have to make this plus.
Oh. Okay.
And now you can call values, or you can do print values. So the idea is that you can have a, now I'm going to just change A to a string hello world. Or A could be like this with double quotes, or A could be with single quotes. A can equal hello world like this. Or A can equal hello world with exclamation points like that with single. You see, either they can have single or double, but I cannot have this. I cannot have something like this. I must choose which one I want. If I'm starting with single quotes, I must end with single quotes. I cannot do this. And similarly, if I'm doing this, I cannot end with single quote like this. I cannot end like this. I must end with double quotes. Does that make sense? So you must stay consistent.
Okay.
The next type of variable we're going to talk about are Booleans. Booleans. So have you guys ever heard of Booleans before?
Yeah, I've heard of them.
If this is Markdown like this, if I don't add anything, it just looks like this.
Essentially, Booleans are true and false commands. Like, for example, if true, then blah, 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 and if false, then blah, blah, blah.
Yes, and it's important. Great, and if this is not going to work, you see, true is not defined, but this is defined. So Booleans only have two values. Either they're true or they're false. Either something happens or it does not. Have you guys learned of probability before?
Probably says that it must be capitalized, otherwise the command doesn't work.
Yeah. Yes, you have to have capital T. Different programming languages will call these different things. Some programming languages will have them all caps. It really depends as well. You just have to kind of be a little bit careful with making sure you're knowing what the programming language needs from you. Is A is true. So the type of A. What do you guys think the type? Okay, so bool. Bool is short for Boolean. Okay, does that make sense? Bool is short for Boolean. Again, one way I remember, so A can either be true or false. Booleans can either be true or false. And a lot of times in statements, if something equals something, like let me show you another way to see this. Like if A equals false, A equals false, right? Like type is also a Boolean. Another way to say it is B. And then this is A. B is equal to 2.5 and C equals 1.5. Can do B less than C. It's 2.5 less than C. What do you think?
We'll say false.
Yes, and then it's saying it's 2.5 less than 1.6.
Something's not saved, by the way. Never mind.
Oh, okay. So it's going to say false. Why does it say false?
Because it's not true.
Yeah, 2.5 is not smaller than this. It's going to say, hey, this is not true. That's not true. That's not true, right?
So as
If
long
it's-
as it's not true, it'll tell you that it's false, obviously.
Yeah, I could even say it's B less than or equal to C. That's how you can do less than or equal to. I could do is B equal to C. That's what it's saying, is B equal to C. One equal sign would have assigned B to being C value. Do you see that? One here it's a double, is equal to. That's what the double means. Is it equal to this? Does that make sense? Is equal to B is 1.6. No, B is 2.5 and C is 1.6. So they're not equal to each other. So B is greater than C. This is checking, is B greater than C? You see that it is, right? 2.5 is greater than 1.6. The same thing with is B greater than or equal to C? Is B greater than or equal to C? Does that make sense? Another way to say it, B is 2.5. If I do B equals 2.4, it'll say false. If I do B equals 2.5, it'll say true. These are Booleans. So I can have a statement where I'm saying that if B is less than C, print B is less than C. Else, print B is greater than or equal to C. Either you can be less than C or greater than or equal to C, right? You see those two options? Either you're less than C or you're greater than or equal to C. There could be a third option that's better. What option do you want? Either you're less than C or what I can write this in another way too. What are three options? B can be less than C. What's another one? That's the exact reverse. Less than, and what's the other option?
Greater than.
See, and there's one more option.
Greater or equal to, less or equal to.
If B is less than C, B can be greater than C, or B can be
equal.
Yes, Abhinav, does that make sense to you? I don't want to confuse you by saying equal to, so I'm going to say double equals, which means is equal to. If I just said this and we're assigning B to being equal to C, this is a very important thing to do, to remember. Double equals says B is equal to C. If I use only one equals, then I'm essentially assigning B to be C. Does that make sense? You have to be very careful in programming, guys. You have to be very careful. You'll get much better at programming through these experiences. So there's something like, so B. So if this is true, whichever one is true, these statements evaluate to true and false. Whichever statement is true will get evaluated. If this is true, then we go here. And the indent is very important. Otherwise, we go here. Does that make sense? Now let me just, for fun, let's just say, okay, so B, we have it as 2.5. Let's just have, let somebody give me another value for C. You can even have negative numbers. Let's make B equal to -9. Okay, B is -9. What do you want C to be?
4.
Okay, C is 4. So is -9 less than 4? Yes or no?
Yes.
Okay, so we expect to come here then. Do you see that? Whichever one is true. If this is not true, we come here, the else. But if we want to check multiple situations, like we don't want to just say, oh, B is greater than or equal to C, right? Because that doesn't give you more information, right? So what if B equals C? That's kind of an interesting thing, right? Like B is equal to C, right? You guys agree? Like the other thing I can say is else if B is equal to C, print B is equal to C. And what should the else now be? So this is saying that B is greater than C, or B is less than C. This is saying B is equal to C. So what should this last word say? What should this say?
Greater than.
B is greater than C. You don't need to specify it. That's kind of implied. B is greater than C. So instead of calling it else if, what Python does is it is lazy again. So it just smooshes them together and says this is elif. You get it? And here the order of these statements doesn't matter. I could have also done the same thing with saying B is greater than C here and then said B is greater than C. And then this else sign would have been this. But it's in comments just so that we understand B is greater than is equal to C. It's the same thing here. It's just the order doesn't matter, but here because only one of these three options can take place, but sometimes the order can matter. Like for New Year's, if you guys had plans and they might have been affected by COVID, you might have had plan A. If this is available, if it's safe to go to my friend's house, then go to my friend's house, right? Otherwise, if it's not safe, maybe watch a movie or play board games, right? You have a second plan, right? But sometimes it turns out that the first option is the most important criteria, is the most important. Then the other option is like, okay, maybe you're checking multiple things. Like if the COVID is not too bad and my parents or sibling can drop me off to my friend's house, right? And my friend's family thinks it's okay that I visit, right? For COVID, then go there, right? But maybe your siblings can drop or your parents can drop you, but your friend's parents do not think it's a good idea for you to come over because of COVID, right? Then something else, right? Maybe then plan a virtual hangout night with your friend for New Year's. You see, like then the next option is that. So sometimes the order can matter when you're running these things. But in any case, these things are Boolean. So we came here because B is less than C is true. Do you see that? Whichever one is true, we come to. Now, if we make C, let's say that we make C equal to, let's say that we made B 9 and C like 100. B is less than C now. Do you see that? Now, oh yeah, it was the same thing. Now let me do this. So C is less than B. You see, this doesn't give you much information. B is greater than or equal to C. So we added this here. So B is greater than C. B is greater than C. Do you see that? Now, if B is 9 and C is 9, B is greater than or equal to C. This one is true. 9 is not less than 9. But now here, both of them tell us that B is equal to C. Here, I just reshuffled those two statements. So sometimes it doesn't matter when only one of these can be true. Either B is less than C, B is greater than C, or B equals C. The way I remember Boolean is it's like boo, liar. What you say is false. That's the way I remember it. Like, how do I remember what this is? I think of it like Boolean is like boo, liar. Do you get it? I don't know, this helps. What you say is false. Boo, you're a liar. What you're saying is false. Does this help you guys out? Because sometimes you might be like, Boolean, how do I remember it? This is Boolean.
Yeah.
Okay, great. That's something I came up with. Boo, you're a liar. Whatever you say is false. So I'm not going to listen to you, right? Like Boolean, bool. So I'm going to talk about list, tuple, and set. So what I want you guys to see is we have a list, a tuple, and a set. We have A equals 1, 2, 3. So A is a list. The type of A is a list. A list can hold all sorts of things inside it. We can have a Santa wish list. For instance, like I can have my wish list, I can have maybe 5. I could have teddy bears. I can have video games, pets, cookies, anything. Do you see that? I have cookies. I can have
Discord Nitro.
Yeah, and I want you guys to actually write a wish list of 5 things that you want for Christmas or that you wanted for Christmas. So I have like a number here. I can have anything inside a list. A list is like Santa's pack. I can have like 8.9.
Oh, are we gonna do that thing like the pick random or whatever that was, like random Santa wish list, random.Santa wish list or something that was?
So how do you input something? 'Cause I put input, then random in brackets, and then should I put equal to Santa wish list or just Santa wish list?
Oh, you don't have to worry about random right now. I just want you to do the wish list. Okay,
Yeah, that
but
was just me
anyways,
messing around.
so this is your Santa wish list. Okay. I just wanted to check with you guys. Is that doing good? So does anybody know how to go through a for loop? So we have elements in a list here. And what we can do is that we have Santa wish list. Let me check Ashwin. Ashwin, do you have this list here? Pet dog, Discord Nitro, new bike. Okay, cool. Abhinav, you have, okay, for I in range, this thing, print this. Okay, cool. So if we want to go through and print every element in Santa wish list, please print every item in Santa wish list. So you can do 4 item in Santa wish list, print item. Okay, so what that does is it goes through every item in this list and it prints the item. We can even have a list, for instance, I can have a class list. This class list can have Sanya. They can have Abhinav. They can have Alexander, Andre, Gayu, and Ashwin. I can even have this class list. So for student or for person in class list, print person. You see it's going through and printing. Now if let's say I call it persona. Now this would crash. Why will this? It'll only print, okay, print person. It'll only print Ashwin. It's going to break.
Because Python, again, as you said before, it's very selective. So when you're saying persona and the other one is person, then Python doesn't know how to compute it. So therefore, you have to change it to match the persona.
Yeah. For instance, if I do for student in class like first persona, I think I don't know what this is. So I can put, it has to match this here. So if I'm printing something, it has to match this. Student and student, this has to be the same. Does that make sense? I can have person, persona 1, and this could be persona 1, for instance. So similarly, I can print out in Yosemite we have. And then what do you notice that this happens here? What's the difference between these two?
Between which two?
This one and this one.
So 113 and 112, right?
Yeah.
So the difference between those is for 112, we're actually adding an element here. We're adding a thing where we're essentially when it says print that, it's giving you you're supposed to print the thing in the quotations. That's one section of it, and the other section is the persona one. And it kind of combines the two together.
Yeah, so this is fixed in Yosemite we have, and then persona one. So for each of these times we're going through them, we're still printing out the same statement. In fact, I can say print end of one for loop. Let me show you what that looks like. End of one for loop. You see that? I could even have this print like this. You see the end of one for loop. In Yosemite, we have Sanya. Then end of one for loop. Then this. This comes from the first time I'm running the loop. Then we go back to the for loop and we go to the next item, which is Abhinav. So then persona one is just Abhinav next. You see, it points to Abhinav. So the order that this is going through is Sanya, Abhinav, Alexander. Oh, sorry, I spelled Alexander wrong. Oh, X.
No problem.
Okay, I spelled okay. So Alexander is the next item. So then in Yosemite, we have Alexander. So Alexander, Andre, Gayu, and Ashwin. That's the same order I go through. We have Abhinav. Then in Yosemite, we have Alexander. So next we're going through Alexander. Then we have Andre in the next for loop. Then in the next for loop, we have Gayu, end of one for loop, and then print this. And then in the last one we have in Yosemite, we have Ashwin, which is the last one.
And I'm assuming there should be a way. Oh, sorry. But I just want to ask, then there should be a way to change the order, correct? Like there should be some sort of command, right?
Yeah, you can shuffle it around. But I don't want to confuse you guys right now. We can shuffle this. But that's sort of how you go through this list in order. Do you see that? I can even go through this video games for item and Santa wish list print item, right? I can even add something called Sanya wants. I can even have my name as an item. You see that my name is Sanya Koller with a smiley, and then I have that with each of these items. You see that my name is the same each time, but what's changing in each loop is item. Does that make sense? If I don't have this, I can even have this fixed wants. Something like this.
I see. So should we all be doing this right now?
Yeah, you could practice this. This is how you write a for loop. A for loop can be very simple for list item in any list, like Santa, wish list, print list item. The types are going to be the type of Santa wish list is a list in Python. We can also get items from this wish list. 5 teddy bears, video games, pets. So from here, what I want you guys to see in this list here, the indexes, this is 0, this is 1, 2, 3, 4, 5, and 6. Or in other words, so if I were to do, so the numbering starts at 0. Santa wish list at 0 will be 5, which is what this element is. This is index 0. So what is Santa wish list at 1 going to be?
Teddy bears.
Yes, exactly. Teddy bears, which is what this is. How do I get hot chocolate?
Santa wish list, angular, no, not the angular brackets, the square brackets, and in between that you say 6.
Okay, 6,
If you want hot chocolate, that is.
Great, and I can find how many elements I have in a list by doing len. Len is short for length. So we like to take short words, right? Len is short for length. There's 7 items, but the indexes go from 0 to 6. So what happens if I try to do Santa wish list at 7? So you might say, oh, we have 7 items, so what's the 7th item? So if we try this, what do you think will happen? Oh, sorry, 7.
Santa wish list 7, I'm assuming. Actually, I don't know.
I think it's gonna bring up an error.
Yeah, maybe.
Okay, yeah.
No, but it says that it has 7 elements then, right? So shouldn't it be something? Oh, no, it isn't. No, wait, no, that would be an error actually, because there's only 6 elements.
So it's going to bring up an error actually.
Yeah, I
List
know.
index out of
I
range.
realized that because it's one more because it starts from 0. That's why it said 7 elements.
Oh. Okay. So one thing I want you guys to do is to so if we try this with 7, this is not going to work here. Another way this can work is if we also call this -1. The reason why this starts at 0 is because you can also have negative numbers. Like let's say that you want to come, you can go in both directions. Either you can go in this direction, which is that you can say this is 0, 1, 2. Do you guys know how to get video games? Video games would be Santa wishlist index 2. Does that make sense? Santa wishlist index 2 will give you video games because that's the index 2. So that's going to give you video games. Oh, okay. Video games. So because we also have something called negative too, where so we can, so this is 0, 1, 2, 3, 4, 5, 6. So going from left to right. We can also go from right to left. So this can be -1, -2, -3, -4, -5, -6, and then -7. Let me just move it all over a bit and have this guy line up like this. Does it make sense? So another way I could do if I want to get hot chocolate, I can do Santa wish list at 6. Or what's another way to get hot chocolate?
Another way to -1.
Yeah, that's another way to do it. -1 is hot chocolate. -2 would be 8.9. You can have a mixture of things. So this is how you can do indexing for lists. If you want to add something to a list, so let's say I want to add something to a list, we can say equals Santa. Oh, one thing I wanted to show you, if we want to add something to a variable, if we want to increment, so we have A is this, okay, so we have B. B is 9. If I want to update B, I can say B equals B plus 1. And what would B be then?
Uh, 10.
Yes, exactly. B is going to be 10. That's exactly what B is going to be, 10. 10, this is 9. So this is like another way to write this, but I also use is this B plus equals 1. That just means updates, adds to B. Or if you do like, so B is now goes from 9 to 10. So similarly, like you update it. So again, what I said is you focus on whatever the right-hand side is, operate on the right-hand side, and then that value will be put back into the left-hand side. So the value will come back here. Does that part make sense?
Yeah.
So similarly, like what we have here, so if B equals B plus 1, we can also say A here is this list, or we also have Santa wish list. Let's say I want to add a few more things. Santa wish list equals, so this is Santa wish list. I can add some more items. I just have to make sure they're in like a list format as well. Hot chocolate. What else should I want from Christmas? What else did people ask for?
Video games, consoles, I guess. Let's see, computers. I don't know, just saying random stuff. Books, stuff like that.
Okay. So now I have Santa wish list here like this. You see that? I can add items to my wish list that I did not have before. For my wish list, for my Santa wish list was just this before with all these items. So now I have all these items inside it. Now I added this list, right? You see that? You guys see that? Now the new length, the new number of items in this list is going to be this. 10 items in this list. So again, I can print out now. How would I get the last element of this list, which is books?
You would do let's see, 9 in the square brackets.
Yeah, I could do a 9 there. Great, because the indexing goes from 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 items. 0 to 9. Great. Or I can also do Santa wish list of -1. So these are lists. We can add things to it. We can change them as needed. These are lists. So the type is a list. Another thing is that we can have a tuple. A tuple is similar to a list, but it can't be changed. So does anybody know why we might want a tuple? We can't add to it. We can't do anything. It's kind of fixed.
Why we want a tuple so that we could have like a fixed variable, maybe?
Yeah, a fixed variable. Yeah, and what kinds of examples can you think of?
Maybe like, for example, if you want, maybe if you want like something that couldn't be overridden or something like that, then you would use a tuple.
Yeah, like it can't be changed. Like this, how much biology do you guys know?
None. I don't wait. What, depends on what you mean by biology, though.
Like, do you guys know about DNA?
Yeah, we know about that.
The 4 main DNA bases.
Adenine, cytosine, guanine, and thymine. Just search that up because I don't know.
We have those 4 DNA bases. Great, great, great job. So we have these 4 DNA bases. We have adenine, guanine, thymine, and cytosine. So we have those 4. So maybe we want to have DNA bases tuple. So that could be like A for adenine. We can have G for guanine, T for thymine, C for cytosine, right? So do we ever think that these DNA bases would change? Yes or no? On our DNA, like, do you think that we would ever change? So these are fixed. So this is great. So this would be an example of a tuple. It's just basically like a list, but it's got these rounded brackets here, and it can't be changed. That's what immutable means. It cannot be changed. So now we have our Santa wish list, right? So let's say I want to have some, let me just update Santa wish list to have teddy bears. So I can also do an append, but a Santa wish list plus teddy bears. And maybe I'll also add some more hot chocolate. And then I'll also have some. So do you see this? Knitting yarn, hot chocolate, teddy bears. You see that there's some duplicates here, right? Is that what you guys notice?
Something happened there. Can you help me real quick? My knitting yarn is white and the square brackets are red.
Oh yeah, you forgot this one.
Huh?
You just forgot the closing.
Oh, I forgot the comma.
Yeah. Do you guys notice that we have some elements that are taking place in multiple times, like teddy bears, right? And teddy bears, do you see that? And what's another one that appears a couple times in this list?
Hot chocolate.
Yeah, hot chocolate, and then hot chocolate as well too. So basically, this is hot chocolate, hot chocolate. So in a list, we can have multiple items that repeat themselves. Okay, now you have this here, and we can call the Santa wish list.
It wasn't running though. Pressing run and it's not working. Oh wait, do I have to? Oh, right, that's why. Sec. Alright, thanks. Sorry.
Okay, no worries. I'm happy to help.
Yeah, because I'm messing around a lot here with random things, so that's why my code keeps messing up.
No, I understand. So here, what we have is we have set Santa wish list. So 5, 8.9 books, computers, consoles, all of this here. So now what do you see happens when I do set? What do you guys see happens with set? So the length of Santa wish list is len of Santa wish list, which is 13. And now if I do Santa wish list, what do you guys notice that this does?
Wait, is this one?
Oh, you have to import random. You have to import the package. We'll talk
All right,
about
I
that too.
forgot about that. Random.
Oh yeah, okay, you got it. Yeah. Alexander, you showed them something with random choice. Why don't you explain? I'll have you explain the random choice thing.
Okay. Yeah. Just let me know when. Should I explain it now?
Yeah, you can explain it now.
All right. So just do this. So essentially, what's happening here is we have import random, right? Import random. When you're importing something, it imports a specific item or a specific function. In this case, we're importing the function random, and basically what the function random does is it changes, it randomizes something from a specific list or a specific set of values that you give it. And for example, here, what we're using it for is we're putting Random.choice. First, you put random, which is the command you want it to do. And you put a period after that. And after that, you have to say what you want it to do. So choice, in this case, we're having this command. It's choosing a random choice from the Santa wish list. So essentially, it'll give us a random value from here. So say I start from here, and then I run this. Input random, and then right now it says cookies, but if I run it again, it'll still give me cookies. So not all the time it'll be the same though. See, like for example, this says 5 now. So basically it gives you a random value out of this list. If that makes sense. I'm not sure if it did.
Did that make sense to you guys?
Mhm.
Okay.
I did explaining things, I'm sorry.
No, you did a good job. Thank you for explaining that. Thank you. I'm going to assign it to Santa wish set. So what do you guys notice? What's the difference between this and this?
Now there's some brackets around them. No way. Different brackets?
Yep, the brackets are different.
The 8 and the 9 are also in a different place. Is it ordering them by... Oh, it's ordering them in alphabetical order as well.
Yeah, it could be doing that, but it's and what do you notice is this is curly brackets. Great. And then do you think that there are more items here or less? So let's just take the length. We can also take the length of a set. Length, len of a set.
Oh yeah, there also is less because it cancels out all of the variables. It cancels out the doubles.
Yes, exactly. So that's exactly a set of unique items or objects. That's how we can often find the unique objects or items in a list. So we could do the length. If I do length of Santa wish set, it's going to actually just be 11 items because 2 of them, like teddy bears, appear twice. So it's going to knock these things out. So this is what a set is. A set just gives you the unique. A list can have everything, but a set gives you the unique. There are 3 types. One is a list, that you can have duplicates, whole items in square brackets. A tuple is like a list, but it can't change. And the last one is a set. A tuple has rounded parentheses, and then a set has these curly brackets, and it just has unique items from a list. And the order may not be preserved. So this one does not keep duplicates. Any confusion? Is it making sense to you guys?
Yeah.
Yeah.
Does anybody know about a dictionary?
Yeah, I can do it if you want.
Okay, yeah. Why don't you tell me what you know about a dictionary?
So just like a regular dictionary, a dictionary in Python is a compilation of all the specific number, like all the specific values in a set, and basically the dictionary can find like what the corresponding value for a set is. So for example, if you have something equals something, and then basically you would have one thing, for example, like name, and that would be in, what's it called again? It would be in quotation marks, and then after that you would put a colon, and then you would put another quotation marks, and then you put the name thing, and then if you type in the name of the list and stuff, then it would give you that specific thing. Sorry, I'm not explaining this very well, but essentially a dictionary is something which can find the corresponding value to a variable in a set, I guess is what you could say.
Yeah, I think you're doing a good job. A dictionary is exactly that. So when you guys are looking up an object in the dictionary, how do you typically look up stuff in a dictionary?
You look for the word, and then you look for the you look for like the section, and then you look for the corresponding word.
Yeah, okay. So basically, I still remember back in the day kind of looking through dictionaries as well. I think that, yeah, those are good times, huh? They're kind of having this giant dictionary to go through, right? Like, so so we're talking here about dictionaries. Okay, great. So back in the day, and I grew up with this as well, where you would have some word that you wanted to look up in a dictionary, and you could see how, and now it feels like a relic, like something from the old vintage thing. Oi, humanism, humanitarian. If you look up a word and it tells you having the interests of mankind at heart, a philanthropist, right? Humanity, a quality of being human, the human race, right? Humanoid, human rights, humble. Humble is conscious of one's feelings, unpretentious, lowly. Humble, deferential, or servile, right? You see all of these things, these are words. And then when you're going through, you can say, okay, I'm in the H section, then there's a J, K, and L section. You see, like dictionaries are organized different ways. They have words at the top, right? So it tells you, hey, we're going from Hoi here, and then at the bottom there's like humanism. And this one is going from humanitarian at the top to something at the bottom, right? You look up a word and you get a definition. Do you see that? You look up a word in the dictionary, and then you get some sort of a definition for that word, right? Does that make sense? That's like how you can interpret a dictionary, a word, the definition for that word. So what we can do is we can similarly have a dictionary. Yeah, this is Markdown, where we have like A is name Monty, age 100, for instance. So if I look at A looks something like name Monty. Okay, so the type of A. Is DICT. DICT is short for dictionary. Do you see that, guys? It's short for dictionary. So if I want to get somebody's name from here, if I want to get name, how can I look up name in the dictionary? Anybody have a thought?
A square brackets, quotation marks, name, close quotation in a square bracket.
Yeah, exactly. Monty. Exactly. That's how you can look it up, Monty, like this. It's a good job. That's how we can look up and see that what it would allow us to do is we have these keys here. We have keys and for dictionary. Key is the same thing as so what a dictionary does is it does mapping. It allows us to go from a word, and then if we have a definition for that word, we can look up a word and get the definition for that word. We can go from here to there. That's the same idea as what they call key and value. It's the same idea. We can go from a key, a word, to a definition, to a value for that. Does that make sense? Key to value, key and value. That's what we can do. Name Monty. If we look up name, we get Monty. If I want to get the age 100, how can I look that up?
Same thing as Monty, but replace the name with age.
Yep. And we have to be very cautious because age is 100. If I try looking up age with a capital A, it's going to complain and say it cannot
Age
find
is
it.
not defined.
Yep. Key error. Does this make sense? That this is a key to a value or a word to a definition. It allows you to look up. We cannot look up Monty in this dictionary. It will not agree with Monty. And because Monty is not a key. You can only look up stuff in the dictionary that is defined, all those words. Monty. It's going to complain. Key error. So it's going to say, I don't know what Monty is. I don't know what Monty is. So that's sort of the issue we're up against. So like, oh, okay, how do we deal with that? But it doesn't, you can't find that.
So what you're saying is it doesn't go both ways, right?
No, it does not. If we want to add something, now let's say I want to change name to being my name. I can go to name and I can, so I have the variable. If you guys remember, we have the variable my name, which is what you guys have, right? I'm not Monty. I can change my name to being this my name variable. You see that? Name. I'm updating. So what this does is it sees if name is already a key in the dictionary. If it is, it updates the value associated with name. Okay, so now what do you think will happen to the dictionary? I'm going to run this and see, this is it before, and now see what happens.
It's gonna type in. The output's gonna be the my name.
Yep, it's going.
What you put as my name.
Yep, it's going to override it. Now let's say I want to add in a new one. Like let's say I want to say A, and I want to look up maybe my wish list. I can assign a list as well. I can say Santa wish list, right? I can have A, I can have my favorite, I can even have favorite season. And let's say I put in summer. So what it will see is this is how we can add in. You see, so I have my wish list. Remember, I have my wish list is the Santa wish list, right? You guys remember the Santa wish list that we have? But I could put a list. My wish list refers to Santa wish list here. You see how I can assign a list to a variable here? It's a value. You guys see that? It's super organized, right? About everything I can say, okay, this is my wish list. I can even have a variable called my class list. So this is how you can add keys. Here, what happens is you add keys. And let's say I want to say, hey, I want to update the age from 100. I can just do age. Somebody give me some value for the age. Oh, wait. Somebody give me some value. Any value. It can be any value.
Integer value?
Any number, anything.
Can it be like a large number?
Yeah, it's all good.
Okay. 9,876,543,210. Why not?
Oh, I can't remember all of them. I was gonna put
9,876,543,210.
Okay, 5 4 3 2 1 987654321 Okay. If I even do this capital Age, and let's say I have this as 1 2 3 4 5 6. Okay. So then what I can do is I'm going to run this here. And now what do you see happen? This was age before. Age was 100. Now what is age?
Now the age changes because it's becoming overridden by the second age.
Yes. So what happened? And my wish list was added in this list was added to this over here. My favorite season, summer, was added, and I added another variable age. Right? There's a difference between lowercase age and a capital letter age. You get it? So what happens is if it checks, if you already have this key, the key is everything to the left. The way that a dictionary works is it's basically like key mapping to the value, key and then value. It's a set of key and values. It's the same thing as a word and then definition for word. Did you guys get it? What you're looking up in a dictionary is the word, that's the key. Everything left of this colon is the key. Same idea. Does this make sense? So whenever you have a dictionary, what's important is to see that these are the keys. If it already exists, so there's a difference between this age with a capital A and this age with a lowercase a. So if it already exists, all it does is replace. So it says, hey, Tanya, you have this age as 100. I'm just going to go by and I'm going to overwrite it. And unfortunately, it doesn't really warn you. You know, sometimes it says, hey, do you want to replace this? You know, sometimes like, you know, your computer, some program will give you a warning. Are you sure you want to replace this file, right? You already have a file that exists. Do you want to replace it? Have you guys seen that? So this does it quietly changes the age for you. Isn't that kind of scary? That's scary, but that's worrisome, right? It's not going to tell you that, hey, this age is 100. Are you sure you want to replace? I mean, you can write code that does that. That's all about having defensive programming where you try to be helpful. But what happens is you can replace, it replaces the value. Otherwise, it adds a new key to the dictionary. It's like it adds a new word, right? Like I could go to this dictionary and I could essentially the way that it works is if I say I want to like go adjust humanitarian, I can go and adjust this word, change this definition, and it doesn't tell me. It says, okay, do you have humanitarian in your dictionary? If so, I'm going to just update the definition for that. Otherwise, let's say I'm adding some random word, like let's say I want to add in, let's say AEGSA, AGSA, all of our initials. I can add in this word does not exist in the dictionary. I can tell you that, right? I can add in this word, right? It's not going to be a key in the dictionary, so it's going to add it in there. Does that make sense? That's the way that a dictionary works. It takes a key and it takes a value. So now if I want to look up anything in this dictionary, for instance, I can get a set of the keys. To get the keys of a dictionary, I can do the following. I can just say A.keys. This gives me the keys, dictionary keys, name, age, my wish list, favorite season, age. And now if I want to get like my wish list, you see that? I can even have my favorite season. These are all the keys that I have. I have my favorite season as well. Summer. Is this making sense? You can look up from my favorite season, I'm getting summer. If I look up capital age, there's a difference between uppercase age and a lowercase age as well. Can I have you guys make a dictionary about some SAT words? You guys all have to take the SATs, right? Because I want you guys to choose, 5 or 6 words. This will be helpful for all of you guys. And if you guys can all make a dictionary, so what we can call it. Any questions on this so far, though? So we can call it an SAT words dictionary. And we can have it like this. We can have maybe, I can show you the example and then a bait. You just take one of the first ones, lesson 10, so lesson amount. You just, you can put it in string like this. So this, we have the word abate. Wait, let me get the definition from here. To become less active. And this has to be in quotes. I can even add a variable like a source of definitions, just in case we want to look at it again. I can add strings, I can add numbers, anything to this. I added this definition like this. I can have this SAT words dictionary. You can do it 2 ways. You can do it this way, And then you can keep on adding words to it. You have the word, then the definition, and wait. So the way that it goes is the way that the dictionary goes is it goes like E. Oh, E. Word. So we can add more words. Like let's say I want to add in another word, like that's how the dictionary looks right now. I can add in abysmal, extremely bad. I can add in abysmal, extremely bad. And then I can add in another word.
How many of these should we have?
Probably 5 or so.
Okay.
Some 5 words of yours, apart from what I've gone through with you guys. So
Right.
this is adequate. Yeah, you want to have an adequate amount of words.
I think I'm done.
Okay. So then the idea is that the dictionary is really cool because you can look up words and get definitions for them. If I look up like adequate, if I try this, it's going to give me an issue because it's going to be like, oh, I can't find this wrong spelling. So I have to make sure that my spelling is on point. Having sufficient qualifications. You see how I can look up a word and get the definition from it? Like as if I was in a dictionary, right? You see that?
Oh, should we include the source of definitions thing real quick?
You can. It's up to you.
It's fine if we don't, though, right? Just
Mhm.
because there's a lot of stuff in there.
Word 3, instead of word 3, you want to put up the word and then the definition. Okay.
Yeah. Also, can you check something for me? Because it's not working.
Mhm.
What did I do wrong here? Do I have to do one of each or something?
Oh, you have to add a comma here. You're missing a comma.
Where?
Oh, I added a comma after savvy. You just missed a comma.
Okay, now it works. Okay, thank you.
Yep, that is a
Forgetting
small
to add
thing.
commas. I'm sorry. Keep forgetting to add commas.
Yeah, you have to be careful. And now if you look up a word like that, the only weakness is it doesn't have the uppercase definitions. So one thing you could do is you could just say abate. And it's like looking up in the dictionary. Become less active, less intense, or less in amount. You see that?
Yep.
This is how you can, and this is another example as one, hello world, another example of lists as well, that you can have lists like with all sorts of things inside lists. You can have having one, an integer, a string, a float.
You're doing this on my notebook.
A
Just
Boolean. Oh yeah. You can have a list having all sorts of things too. So there are lots of things. So this is a key and value. Does that make sense, guys? Key and value. So if we want all the keys, we can also see this as well. There is another example. This is a fun example of having a dictionary where you can have, essentially, you can play out a game. And this way that this game works is you have the user kind of guess the definition of a word. What does this word mean exactly? You have a key to a value, a key 1, value 1, a key 2 to the value 2. So it's like a flashcard game for karate moves. Shizentai, natural scan, Tokuzuki, straight punch, Gyakuzuki, reverse punch. Have any of you guys done karate before?
the movie Karate Kid? Or
Yeah, karate seems like a fun. I used to.
I mean,
do
I've watched
karate.
videos about. I've watched like TV shows with karate in them. I used to do taekwondo though, so no.
Ah, so the idea is that it's a fun game, and it's like it's a dictionary where instead, what do you guys notice are the keys here in this situation? You basically want to see if people have learned karate. It's like a flashcard where on one side you have the word, on the other side you have a definition. You can quiz yourself, you can quiz other people. So these are the keys. This is the keys, and these are the respective values for them. So shiz and tie. So what do you notice are the values? And what are the keys from this photo?
What do you mean?
Oh, so these are the keys here.
Mm-hmm.
And these on the other side are the values, key, and then
Yeah.
the value. So what are the keys typically in the photo?
The key of the photo is the term.
And on the top, right?
The value is like the subheading.
Yeah, and this could be if you want to quiz somebody, like what does Chisentai mean? What does Tokuzuki mean? What is Gyakuzuki? What is Eijuki? Sorry if I'm mispronouncing this name. The Gaiden Barai, Oizuki. What do these terms mean? Oizuki, front lunge punch, which is what this is, front lunge punch. Shizentai, natural stance, which is what this is here. So that is if one side of the flashcard says this thing, and the other one says, and you flip it around, it's the definition. Or you could flip it around if you want to say, okay, how do you say natural stance in karate terms? Then you flip them around. Maybe you're then quizzing them the other way around. But in our case, for our flashcard game, for instance, it would have been, okay, we have SAT words. What is the definition of a given word, right? We have abate. What is the definition for it, right? So these are the dictionary and then a set of keys. So that's how this works. You have a set of keys here. Now what happens is this is what you were talking about, Alexander, where you have the keys. The keys for the dictionary are, shiz and tai, Tokuzuki, Oizuki, Gyakuzuki, Gaiden Barai, and Eijuki. These are the vocab dictionary keys. And these are the respective values. We can get, dictionary.keys gives us the keys, and the dictionary name.values gives you the values. And then what you can see here is that this maps to this maps to this in the order. It lists out the values. Does this part make sense?
Yeah, and then the reason he does the shuffle is because he doesn't want it to just match the values one for one.
Oh, no, he wants it to match, but each time, the idea is playing the game. When you play the game, so
Like it's supposed to be different every time.
Yes. So this is some collab, which is free and available, which is nice. So let me try running through this task one. So what the random does is it's just going to shuffle. So what happens is it's going to ask you each time, it's going to ask you one of these keys. And you have to put in the definition. You have age key, which is rising block. So I can guess. It asks you, what do you think this is? I can say age key is rising block. Okay, correct. Rising block. What does chokuzuki mean? Anybody guess? Can you say
Frontal punch.
frontal punch?
Probably wrong.
Oh, it says straight
punch.
punch. So it keeps track of those. And then this is oizuki. Anybody remember what oizuki was?
Then that one's probably frontal punch.
Yeah, frontal punch. Oh, it's
it's called different. Never mind.
frontal
I know what
punch.
this one is for sure though. This is like a downwards block. Should be downwards. Down? No, wait, what?
A down block, yeah.
I'm getting all these wrong. I'm so bad at this.
And then I'll just show you again for another second. This is Gyakuzuki reverse punch, right? If we get it right, then it tells us, we got
Ronnie
it.
has some random names for these.
Then Shizentai can just say some random thing. And it's gonna be wrong in natural stance, right? And so you can play this game here. You can put it all together and you can have a series of if statements and using this dictionary of these corresponding definitions and see do the people get them right. You know, if you've done them right, it tells you how many right out of these 6 words, 3 correct, 3 wrong. So that's how you can make a flashcard game using what we learned today.